In this chapter, we shall look at how to create CL programs. We shall also look at the debugging facilities available on the AS400 and see how to test the programs to ensure their correctness. Let us begin by creating a CL program. First of all, we have to create a source physical file to which we can save our programs. We do this using the create source physical file command. We specify QCLSRC for the source physical file name parameter and programs for the library parameter. To start the SEU editor, we work with members PDM command. We use the F6 function key to add a member to the source physical file. This brings us to the Start Source Entry Utility screen. Enter the name of the source physical file and also the library name. Also specify a name for the CL program. For the source type parameter, we should specify CLP when creating CL programs. Also, it is a good practice to always include some description about the program in the text parameter. CL is a free format language, so you can just type in the code. If you need any help for writing any of the commands, you can place the cursor on the line containing the command and press the F4 key. You will be prompted for the parameters. After entering the CL commands, press the F3 function key to exit from the current editing session. Type the option Y for the change create member parameter and press the enter key. As you can see, our program has been saved as a member in the QCLSRC source file. Let us see how a CL program is compiled. There are two different ways of doing this. Either we can specify option 14 against the program name or use the create CL program command. To specify any parameters, press the F4 key, otherwise the OS400 will take the default parameters and create an object with the same name as the source member. Pressing the F4 key brings us to the Create CL program display. Here we are prompted for the required parameters. To specify other parameters, press the F10 key. Now we will be prompted for the additional parameters. Here we can specify a number of options. *source and *no source are used to specify whether the compiler listing should include a copy of the CL program or not. *cross-reference and *no cross-reference specify whether a cross-reference listing should be included or not. *generate and *no generate values are used to indicate whether the compiler should create a program object or not. *second level and *no second level options are used to specify whether to include second level help text for error messages in the compile listing. The user profile parameter is used to specify the kind of authority the user has when running this program. A value of *user means that the user of the program has only the authority associated with his user profile when running the program. A value of *owner indicates that the user should also have the authority of the program's owner in effect when running the program. The log commands parameter is used to indicate the degree to which the CL program should be logged in the job log. We specify *yes when we want to log each line of the program, *no when we do not want to log the program in the job log, and *job when we want the program to be logged based on the log specification in the job description. OS 400 provides the facility to retrieve the source statements of a CL program from the compiled object. The allow retrieve source parameter specifies whether this facility should be provided for this program. The replace program parameter specifies whether this program should replace an existing program if the compilation is successful. On the target release parameter, we can specify whether the program is to be compiled for this version of the OS 400 or for an earlier version. The authority parameter specifies the kind of security that is applicable for public when they try to access this program. A value of *library create authority indicates that the authority for public is to be taken from the library in which the program is going to be placed. When a library is created using the create library command, the authority parameter is used to specify what kind of authority the public have to objects that will be placed in this library. This value will be picked up from the authority parameter when creating the CL command. Let us look at a compile listing. At the beginning of the spool file, we have a listing of all the parameters on the CL command along with the values that we have specified. This is included when we specify the *source option. This is followed by a listing of the CL program. Then we have the cross-reference listing included when the *cross-reference option is specified. Here we have a listing of all the fields along with the statement number on which they are defined, the type and length of each field as well as the statement numbers of all the statements that reference this field. We also have a listing of the labels used in the program. Notice the error messages. Finally, we have a summary of messages generated by the compiler. Each message has a severity level associated with it. Here is a summary of what each severity level means. Next, let us look at the retrieve CL source command that can be used to retrieve the CL source from a compiled object if the CL program had been compiled using the allow retrieve CL source option set to *yes. The retrieved source is saved as a member to the source file specified. OS 400 includes a prologue at the beginning of the file, and all commands are retrieved in the keyword form. Any comments included in the original source file are lost. Let us move on to the AS400 Debug Facility. It provides us with two methods of sequencing through our programs to trace the errors that occur at execution time. They are trace and breakpoints. With trace, we specify a range of statements to be monitored along with the variables whose values we want to monitor. When we run the program, it is allowed to run normally without interruption. The trace data is put into a file and can be viewed later. When breakpoints are used within a program and the program is run, it stops at each breakpoint and displays the values of the variables. Before debugging our applications, it is always better to make a copy of the objects being used by our application into a test library. This will ensure that any errors in our programs will not affect our original data. Make sure that we are using the test library when debugging our programs. We use the start debug command to put our job in the debug mode. On the program parameter, specify the list of programs that you want to debug. We can always add programs to or remove programs from the debug environment by using the add program and remove program commands respectively. The default program parameter allows us to identify a default program name that will be used for some of the debugging commands. We will see the use of this parameter in a little while. The maximum trace parameter is used to specify the maximum number of trace statements to be allowed in the trace file. The trace full parameter is used to specify what has to be done when the maximum number of trace statements is reached. Here you can have two values, star stop trace that terminates the trace function and star wrap that specifies that the contents of the trace file can be overwritten when it becomes full, starting from the beginning of the file. On the update production library parameter, specify star no. This will ensure that we do not update any objects in a production library. Let us use the add breakpoint command to add some breakpoints to our program. On the statement parameter, we specify the statements at which the program execution should stop. One important point to remember here is that the program stops just before executing the statement at which a breakpoint is specified. Hence, the values of the variables that will be displayed is the value contained in the variable before the statement with the breakpoint specified is executed. On the program variable parameter, we specify the variables whose values are to be displayed. Each variable name should be enclosed within apostrophes as they contain a special character, that is, the ampersand sign. The start and length parameters are used for character variables. When we do not want to display the entire character string but only a portion of it, we can specify a starting position and the number of characters to be displayed. The output format parameter is used to specify whether values should be displayed in character or hexadecimal format. When we specify a breakpoint at a statement within a loop and we do not want the program to stop each time it goes through the loop, we can specify the number of times the statement is to be executed before the program stops. This is done in the skip parameter. On the breakpoint condition parameter, we can specify that a program is to stop at the breakpoint only if a particular condition is true. On the program parameter, we specify the name of the program to which the breakpoint is to be added. Here we can also specify *default program to indicate that the breakpoints are to be added to the program that had been identified as the default program on the start debug command. Now we can call the program. The program stops execution at each of the breakpoints we have specified. At each breakpoint, the display breakpoint screen is shown. Each of the variables is listed along with the relevant information such as the data type, length, and value. From a display breakpoint screen, we can use the F10 key to move to a command entry display. Here you can use most of your CL commands. To return to the breakpoint display, we press the F3 key. When we press the F3 key, the program will continue and stop at the next breakpoint. Trace, as we mentioned earlier, is different from breakpoints in the sense that trace allows the program to execute without interruption. The trace data can be viewed when the program ends. The add trace command is used to apply trace to our program. On the program variables parameter, we list the variables whose values are to be monitored. On the statement parameter, we specify the range of statements we want to trace. On the output variable parameter, we can specify whether we want the values of the variables to be recorded only when their values change or always. Finally, on the program parameter, we specify the name of the program to which trace has to be applied. Here we can also specify a value of *default program to indicate that the trace is to be applied to the program that had been identified as the default program on the start debug command. Now we can call our program. When the program completes execution, we use the display trace data command to view the trace data. Here you have the statement numbers followed by the value of the variables. Remember, the value of the variables shown in the value before the particular statement has been executed. You can use the page up and page down keys to view the contents. To clear the trace data, we can either set the clear parameter on the display trace data command to *yes or use the clear trace data command. To come out of the debug mode, we use the ndebug command. In case you make any changes to your program and recompile it while in the debug mode, you should either end the debug session and start it again, or use the remove program and add program commands on the recompiled program. Otherwise, the debug mode will continue to refer to the old version of the program. Another tool that can be useful in debugging your program is the program dump. It contains information about the job and the program, followed by a listing of the messages in the program message queue, and finally a listing of all the program variables with their data type, length, and value. To obtain a program dump, you can include the dump CL program command within your CL program at the location in your program where you want the program dump, or by typing D in response to the inquiry message when you execute your program. In either case, a spool file qppgmdmp is created that contains the program dump. Summary. In this chapter, we saw how to code and create CL programs. We looked at the parameters of the create CL program command. We also saw the retrieve CL source command that can be used to retrieve the source code from a compiled program. We also saw how to test and debug CL programs using the debug facilities. We also saw the trace and breakpoint facilities of debug. We also had a look at the program dump facility.